Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 3rd, 2025, so just yesterday. This paper introduces a new method that improves spatial control in image generation, reducing depth estimation errors by over 10% compared to a leading baseline. The paper is titled, Heeding the Inner Voice, Aligning ControlNet Training via Intermediate Features Feedback. And it achieves this by basically listening to the model's inner voice throughout the entire creation process. The authors show that by enforcing this control from the very beginning, they can create images that are both higher quality and more accurate. Also, the authors shared their implementation on GitHub, and it's quite comprehensive. You'll find everything you need to get started, including scripts for training and evaluation, pre-trained model weights, and even a Jupyter notebook to quickly test out inference and generate your own images. A really complete package. Alright, so this first figure really highlights the core problem the authors are tackling. On the left, we see a comparison. The top row shows a baseline model, ControlNet++, and as it tries to enforce control for more and more of the generation steps, the image quality just falls apart. You can see these strange artifacts appearing, but the new method, on the bottom row, stays consistent and high quality throughout. The plot on the right quantifies this trade-off for the old method, using two key metrics. First is root mean square error, which measures control accuracy, so lower is better. The second is fresh A inception distance, which measures image realism, and again, lower is better. The plot clearly shows that as control accuracy improves, the image realism gets worse. You just couldn't have both. Okay, so this diagram shows the new InnerControl architecture that makes this all possible. On the left, you have the standard inputs, an image and a control signal, like a depth map. The core is the Diffusion module, which uses a U-net, a common U-shaped network for image tasks. The key addition is this new alignment module on the right. It taps into those stable intermediate features from the U-net, tries to recreate the depth map, and then calculates an alignment loss. This loss is a correction signal that forces the main model to stay on track from the very beginning, ensuring the final image is accurate. Moving to the results, this table shows a head-to-head comparison on the multi-gen 20M benchmark. It pits the new InnerControl method against several others across three tasks: head edge, line art edge, and depth map. The scores measure control accuracy, where lower error is better, image quality, also lower is better, and text relevance, where higher is better. And across the board, especially for depth and line art, the new InnerControl method consistently achieves the best scores, significantly reducing error while keeping image quality high. This really validates that new architecture. And those numbers translate directly into much better pictures. This figure gives us a fantastic visual comparison. We're looking at three control types: HED edge detection, depth, and line art, pitting the new method against its rivals. The results are also shown at different guidance scales, which is a setting that controls how strictly the model sticks to the input image, and the difference is clear. In the red boxes, you can see the other models either add messy, scratchy lines or just fail to match the control image, especially for depth. The new method, however, stays incredibly clean and accurate. So, as we saw in those images, the results are really quite striking. In conclusion, the InnerControl method offers an elegant solution to a persistent problem. Previous models struggled because they only checked for control accuracy late in the game, creating that trade-off we saw between accuracy and image quality. This new approach introduces an alignment loss, which uses small helper networks or probes to check the model's internal work from the very beginning. This ensures the final image is high quality and precisely follows the control map. That's all for this week's AI Research Roundup. Thanks for tuning in.